Wondered what is a logarithm? I still remember during my schooling when my maths teacher used to say we need to take log on both sides when we least expect it. Because we don't know the definition, or we didn't know at that time the definition of logarithm. We didn't understand at that time, at least I didn't understand at that time, what exactly is the meaning of logarithm and why he or she is taking that and introducing that in middle of a problem out of nowhere. What is the relationship between an exponent and a logarithm? And where all do you use logarithm? Is logarithm that important? Do we have to really open a book or take a calculator to calculate log of some number if we have other forms of solving a problem? Does really logarithm help us reduce the number of steps in solving a problem and the complexity of a problem? Let's find out all the answers to your questions in today's video. So hi, I'm Deepthi. Welcome back to my channel Trick or Treat with Mathematics. Hope everyone is doing great. So in today's video, as the title suggested, we will be saying everything about logarithms that you need to know. So there will be a series of videos on logarithms, but this is the first part where I'll introduce you to the concept of what exactly a logarithm is and the relationship between an exponent and a logarithm. So without wasting any more time, let's jump right into the video. But before that, please hit the subscribe button down below and share my channel to whoever in need. So without wasting any more time, let's jump right into the video. Question in my introduction: what is the relationship between exponents and logarithms? That is what we'll see first before we dive into the logarithms. Because exponents and logarithms share an inverse relationship. They are opposite of one another. You need to understand exponents before we solve or understand logarithms. So let's start with a quick recap on exponents before we jump into logarithms, and then let's try to connect both of them together. What is an exponent? Suppose I will multiply 2 5 times. Do you every time write this in order to say that this is 2 multiplied 5 times? Or do we use 2 power of 5? We use this because it is not always feasible to multiply a number by n times. Suppose for example 9, I want to multiply 9 100 times. Can I write? The entire board will be taken to write 900 times. For that, we will express this in the form of an exponent. So here 2 will be the base and 5 will be the exponent. In the same way, 9 will be the base and 100 will be the exponent. So in short, if b is the base and if the base is multiplied n times, then we can represent this as b power of n, whereas small b is base and n is an exponent. For now, let's consider b as real number, the base as real number. Okay, this is the underlying concept of exponents. Now, with this concept in mind, you might also have been introduced to certain laws of exponents, right? So what are the laws here? The first law is a power of m into a power of n. We know that is a power of m plus n. A power of m by a power of n is a power of m minus n. And then again we have a power of m whole to power of n is equal to a power of mn. And then we have ab. These are of same bases, but these are of different phases. We get a1, bn. And also we know that a by b whole power of n is also a power of n by b power of n. And in short, we know that a power of 0 is 1. So all these are laws of exponents. Am I right? You might have been introduced to all the laws of exponents much earlier in your education while you were dealing with exponents itself. These are all very important in mind while solving even logarithms too. Now, you need to understand the exact relationship between logarithms and exponents. You might be asking me a question. If we know the laws of exponents, if we know how to calculate or how to represent a number in the form of exponents, what is the use of logarithm? Let me show you an example. Suppose I will ask you this, 10 power of x is equal to 1000. Okay, and I ask you to find out x. So what is the value of x that you would give me? 10 power of x and 1000 can be written as 10 power of 3. And you would say that it is simple, x is equal to 3. Okay, now in the same way, I want to ask you what is the value of x when 10 power of x is equal to 7? Will you be able to give me the value of x when this is the equation that I give you? You will be facing some difficulty while solving for x in this equation because there is no direct way to solve for x. In such cases, we use logarithms. Logarithms are nothing but the solutions, or it will be useful to find the solution of exponential equations or any equations for that matter. They will be useful to find the solution in a very easier fashion. And in order to get the log of any value, we either use logarithm tables or we use a calculator where we have log written on it. Please note that the calculator represents log to the base 10 or log to the base e. I will jump on to the bases a bit later, but for now, this is the main use of logarithm. In this case, what would be the value of x? What we will do is, this will be denoted as base, right? From exponents, we know that this is the base and this is the exponent and this is the answer. So, we know that when 10 is raised to x, you will get 7. So, we need to find the value of exponent. What we'll do? We'll convert this into logarithm. So, what you do is, you write log. This is the base. Put the base in the base itself as the name indicates. Okay. And then this is the answer. Copy the answer exactly as this one and then equate this to x. So 10 to the power of x is equal to 7 can be rewritten as log 7 to the base 10. That is, the value of x is nothing but log 7 to the base 10 is nothing but 0.85x something, but 0.8 is the value. And you will get this value with the help of logarithms tables or with the help of calculator. This is how you easily find out the value of x using logarithms. This is the definition of logarithms. In short, logarithm of a number is nothing but whenever a power x that must be raised to 10 and it gives you a certain value n, for example, then in order to determine the value of x, we use logarithms. That is nothing but whenever you need to find the value of x that must be raised to the base b in order to get n, then this is where we use logarithms to get the value of x. So this is the basic concept of logarithms that you need to know. You can even get the value of x here by using logarithms. How do you get that? For example, when I say that 10 power of x is 1000, we want to find the value of x without using the laws of exponents. If you want to apply logarithms on this, how do? We'll simply take log on both sides. So after taking log on both sides, we get 10 log 10 to the power of x is equal to log 1000. And you know for a fact that log 10 to the power of x is equal to log 10 to the base 3. Now use 3 log 10 is equal to x log 10 and this will get cancelled and x is equal to 3. This is one of the laws of logarithm that we will be dealing later, but this is how you get the value of x in this equation by using logarithms. Okay. I've told you that in general, in calculator, we'll see the value of logarithm to the base 10. Why is that so? Why always 10 is considered as a common logarithm? Remember, 10 is log to the base 10 is considered as a common logarithm. Why exactly is that? I've done my research on that and they explained that logarithm to the base 10 is a common logarithm because of our decimal system. Our decimal system is represented to the base 10 and we have 10 fingers. Some theories also say that we have 10 fingers as a human being. 10 is a convenient number to use. That is the reason 10 is commonly used and it's called as a common logarithm. Okay. However, there is another base of a logarithm that we use usually, that is e. Call that as log to the base e, log 10 to the base e. If you ask this is the natural logarithm. So log to the base e can be represented as natural logarithm, and e is nothing but another constant that is frequently used by scientists and mathematicians that occurs naturally. So this is a constant that occurs naturally as pi. You know the value of pi, right? 3 is equal to 3. Pi is equal to 3.14. So e also has a constant value that is 2.7. It goes on. But yeah, so the value of e is 2.7 and value of pi is 3.14. So the another base that we use in logarithms is nothing but log to the base e, which is called as natural logarithm. And we also represent this as ln only, that is ln. This is called as ln, but this is how it's represented on the calculator. So whenever we have log, it means that it has some base but commonly used as 10. Whenever we have this written here, it is a natural logarithm, and this is also written as ln. Okay, so these two are the usually and commonly used bases across the globe whenever we deal with logarithms.